Hello class 12. Today we are going to deal with the same dipole moment as the earlier my lecture. You go through in the YouTube channel Chemistry with Kurishesha, you will find the dipole moment in brief, short, but with a very logical concept. Now here, dipole moment is nothing but the separation of charge between the two atoms in the same molecule, means within the same molecule. Now here they've said haloarenes are less reactive than haloalkanes. Explain why. This is related to the dipole moment. ये dipole moment का relation में ये stability और unstability यहाँ पर saying. Now this is haloarenes. It is nothing but aromatic compound bonded with one of the halogen atom. और ये क्या है हेलोएल्केन्स आर नथिंग बट एलिफेटिक कंपाउंड्स वेयर वन ऑफ द हाइड्रोजन रिप्लेस विद द let's say fluorine, chlorine, bromine, iodine. These are all halogen groups. Okay, now let me draw first of all the haloarenes. Haloarenes means it is an aromatic compound with a 3 pi system. 3 pi system means 3 pi bond. Now yes, I've taken chlorine, right, and I will choose for the aliphatic compound. Let's say I'll say ethyl, sorry, CS3, ethyl chloride. Okay, now this is also having 3 pair of non-bonding electron, as you know that three pair of non-bonding electron in the case of the chlorine, right? 3 pair of non-bonding electron. So they have asked me, I have to explain the stability in terms of the dipole moment. See here what happens. This is aromatic, means haloarenes, and this is haloalkanes. Haloalkanes means single bond, saturated hydrocarbon, C single bond in this one. Now I'll come to there. Here the dipole moment is almost 0. But here the dipole moment is not 0. So this is more having dipole moment than this one. Okay. So here the what happens, the dipole moment of, let's say this one will say A, this one will say B. So B is having more dipole moment than A. Now I am going to show to you why it is so. First of all, let's bring about the chlorobenzene, right? Now 3 pi system within the ring. Chlorine with the 3 non-bonding electrons or 3 lone pair of electrons, right? So what happens in the case of the chlorine? This non-bond, one of the lone pair of electrons or the non-bonding, it undergo delocalization within the benzene ring. So it undergo the resonance. This is called the resonance, right? Now here they have developed it has donated to make the double bond, so they develop positive charge and 2 lone pair of electrons stayed there. Now this is a partial double bond, not purely double bond, but partial double bond. Now here will be one of the shifted pi bond. So one of the pi bond will come here. This will go at a para. Meta में कभी भी देखो ये shift नहीं होता. That's why this will ortho para directing. Now when you come back to here, you find that this is here, this is here, this is shifted back to here, and this is nothing but chlorine with a double bond, but one of the has been lost here to form the double bond. So here is a double bond, partial double bond. Now when this goes shifted back, it go and shift it, and this is going to neutralize it. So what happens here, and this is called the resonance. I have done a bit short, okay. So here it goes, is shifted, and here only the orientation or the position of the pi bond has changed it here. So what happens? This has developed the partial bond character or not? Yes, the bond become shortened. Now when you see here, CCl become, as you know that the double bond is always shorter. So this is here the bond length shortened. But in the case of the methyl or ethyl chloride, though chlorine is having 3 non-bonding electron, but it doesn't go there because there is no alternate double bond. Alternate double bond has to be there. but it has got no ring, no aromatic ring where they can delocalize, or it has got no conjugated double and single bond like alternate. There is no such. So it will remain as it is. So there will be a net dipole moment is there. Here the dipole moment or the net force is not equal to 0. Not equal to 0. And here because of the development of the partial double bond, so यहाँ पर क्या हो जाता है कि ये डबल बॉन्ड रहेगा तो वहां पर आपका डाइपोल मोमेंट आपका नहीं बनेगा, क्योंकि यहाँ पर पॉजिटिवली चार्ज and carbon is also highly positively charged, you know that, and here also carbon, so there is no separation of the charge. तो यहाँ पर क्या हो गया आपका डाइपोल मोमेंट इज इक्वल टू 0 ना. सो आप अगर कंपेयर करेंगे, अगर ये दोनों के बीच में ए एंड बी बोल करके, तो आपका यहाँ पर देख लीजिए बी इज हैविंग मोर डाइपोल मोमेंट देन ए. Finish? I hope it should be finished. You pause and just copy it. It is because of the resonance. It develop a partial double character. So the dipole moment is lost. They have got the similar charge. But here the charge separation is there because there is no double bond. Resonance is not there. So there will be net negative charge, means this will remain electronegative in character purely. But here in the case of the aromatic ring, chlorine has lost its identity of electronegativity because the positive charge has developed because of the delocalization. पर यहाँ पर delocalization नहीं हो रहा है, तो यहाँ पर आपका net dipole moment है. यहाँ पर आपका, that's why B is having more dipole moment, but A is having this one. Haloarenes is not at all having any dipole moment. So this is the explanation for this one. Please copy it nicely. Pause and copy it, okay? Pause and copy the lecture and you'll get the... Okay then, till then, those who are new to my channel, please subscribe. Those who are all following me for the last 1 month or so, you please share with your friends, press the bell icon and press the like button if you feel so. My lecture is short and giving you the proper information. Till then, goodbye. Thank you.